So today we're going to take a look at the constant functions and at the identity function and their graphs. The constant functions are functions of the form f of x is equal to c, where c can be any real number, but is a constant. What the constant function does is it takes in any real number and it spits out whatever that constant c is that's used to define the function. Before I give you the general form of the graph and the general properties of the constant function, I'm going to give you a specific example. We're going to take a look at the function f of x is equal to 5. This is a constant function with constant 5 used to define it. What this does is for any value of x, f of x will be 5. So if you give it x equals to 0, then you're going to get f of x is equal to 5. If you give it x is equal to 1, then f of x is equal to 5. If you give it x is equal to negative 7/2, then f of x is equal to 5. So you get 5 no matter what you put into it. And if you look at these pairs, 0, 5, 1, 5, negative 7/2, 5, and so forth, on the Cartesian coordinate system, so here we have 0, 5, and 1, 5, negative 7/2, 5. And you see that all of these points are on this same horizontal line where y is equal to 5. And that's the graph of the function f of x is equal to 5. And all our constant functions are going to hold true to that pattern. If you have a function, f of x is equal to c, where c is some constant, then what you're going to end up with is the horizontal line through y-intercept 0, c. The domain of this function is, of course, every real number. So we can write that using our special Blackboard bolded notation for the real numbers or as an interval. And of course, the range of this function is the set that contains only the value c, because c is the only thing this function can return. Generally, constant functions have no x-intercepts. The only exception is the function f of x equals 0, which gives you the x-axis. And this is an even function. If you recall, an even function says that for any x, f of negative x and f of x are the same value. And if you look at this, you'll see that the constant functions do satisfy that criteria. So now let's take a look at the identity function. The identity function is defined as the function f of x is equal to x. So what this function does is it takes as input any real number and just returns what it's given. So if you give it x is equal to 0, you get f of x is equal to 0. If you give it x is equal to 1, you get f of x is equal to 1. If you give it x is equal to negative pi, you get f of x is equal to negative pi. X is equal to negative 4, f of x is equal to negative 4. So it just takes any value for x and returns it. You may also recognize this as a linear function. So an equation for a line whose slope is equal to 1 and with y-intercept 0. So the graph of this function is the line that goes through the origin and exactly bisects the first and the third quadrant into two equal pieces. And the points on this line are all of the points whose x and y coordinates are the same. This line has exactly one x-intercept and one y-intercept. Both are the point 0, 0. Both the domain and the range of this function are the set of all real numbers. It's an increasing function. And you'll note also that the identity function is odd, and that it is symmetric about the origin and satisfies the algebraic criterion that f of negative x is equal to the opposite of f of x. And now we can add the identity function as well as the family of constant functions to our function library for future use.